Welcome to Biology My Passion. I am Soumya Harikrishna. Today we are going to start a new chapter in class 9 chemistry, matter in our surroundings. This is the first chapter. So we are actually understanding what is matter, what are the states of matter, can matter change its states, and what happens during that time. So first we have to understand what is matter. You just look around yourself. You see so many things in your room. You are using a gadget to watch my video, maybe a tablet or a mobile or a computer. So that is actually made up of matter. Then your table, your chair, your books, your clothes, everything around us is made up of matter. But is this only the things which we can see made up of matter? What is there in your room? What is filled in your room? There is air filled in the room. So is air matter? So air also is matter. Then what is not matter? I am feeling hungry, or I am angry, I am sad, I am happy. All these emotions are not matter. So we should have a clear definition for matter, something to say whether it is matter or not. We should have some characteristics for it. So we can define it in two terms. First, matter is something which has got mass. So even if you say table, it has mass, book has mass, mobile has mass, and even air has mass. But what about your feelings? Do they have mass? No, so they are not matter. Another thing, since they have mass, they have volume also, or they need space to occupy. Your book needs space to occupy, your table needs space, your gadget needs space, your pillow needs space. So even air needs space. Only thing, air will be filling in whichever place available, but it needs space. So two characteristics or two things we have to tell when we are defining matter. One is matter has mass, matter has volume, or it occupies space. Now, what is this matter made of? Any matter, if you break and break and break and break and break, finally you will come to something like particles. So every matter is made of small particles. These small particles are very tiny, very, very small particles. How do we know that these particles are small? In Indian ancient philosophy, we used to believe, even now we believe, that everything, every matter is made up of 5 elements. That is called a Panchatattva. Air, water, sky, earth and fire. So these are the 5 tattva. Even Greek philosophy is almost similar. But now we are going to deal with in the perspective of science or chemistry. Chemists have divided matter into two different classifications. One based on its physical nature, second based on its chemical nature. In this chapter, we are dealing only with the physical part of this matter, and later chapters we will learn about chemical also. So let's start with the characteristics of particles. So what are the characteristics of particles? We will discuss one by one. First, particles are very small or tiny in nature. They have space in between them. Constantly they are moving and they attract each other. So how can we say that particles are very small in size? You take a glass of water and you measure the level of water using a marker pen. Then you add 1 spoon of sugar to it. Then you add 2 spoons of sugar to it. But is there any increase in the level? No, you will not find any increase. Then where did the sugar go? First you can see it is going and depositing at the bottom. Then when you stir it, it will dissolve. Dissolve means what? These particles of sugar will be going into the space between the water molecule. So that means the particles are very small, so they can go inside. Another experiment in your textbook is take potassium permanganate. Potassium permanganate crystal is something which gives a purple color to water. So if you put them in water and then you keep on diluting the water, even if you dilute up to 100 liters, still that color will be there in that liquid. Why? Because even that small crystal that we put has got millions of particles in it. Or the same is applicable to Dettol. Why we are using Dettol? Because we are very familiar with the smell of Dettol. So if you put it in a cup of water, then take little bit and dilute, but still that smell will be retained. That means those particles are still there. That means particles are very tiny in nature. The next characteristic is have space in between them. So these particles are kept close, but still there are certain spaces available in between the particles. But it varies from different matter, that is matter can be in solid form, liquid form and a gaseous form. If it is solid form, all particles will be very close together. But in liquid, they are little more spaced out. Gas means they have enough space between them. Okay. And the same thing can be illustrated with the previous example. That is, when we are adding sugar, I told since it is tiny, it can go into the space between. So that means there is space so that the sugar can go inside, right? Or the same way when we are making lemonade, or when we are making tea or coffee. So all these particles of one substance is getting into the space of another one. That's why we are getting a solution, right? So they have space in between them, but the amount of space varies in different types of matter. Next is, these particles are constantly moving. That means when we increase the temperature, they become even more faster. Okay, because they keep on moving, but if you increase temperature, they start moving very quickly. For example, if I buy a packet of agarbatti or incense stick and I am keeping in one corner of my room, I will not get the smell until and unless I go near it, take one agarbatti and smell it. I will get the smell. But when I am burning it in one corner of my room, I need not go near it to get the smell. Even if I sit in the other side of the room, I will get the smell. Now what difference has happened? Initially, the temperature was less. The particles were there, they were moving, but the movement was not enough to reach my nose when I am sitting in another corner. But when I increase the temperature, burning means temperature is increasing. Now particles got more energy. They started moving quickly and they reached my nose. I am sitting far away. So when temperature increases, they start moving quickly. And they attract each other. These particles, they attract each other. The force of attraction is there. But this force of attraction varies in different matter again. If it is solid, they are very close. That's why even in solid, different solids will have different kinds of attraction. For example, if I take a small chalk, I know that nowadays you may not be familiar because your teachers may be using whiteboard, but when we were small, our teachers used to break the chalk because sometimes it will become rough, they would break it off. It's very easy, or if it falls down, it will break into pieces. So this chalk, we can break it easily. Why? Because force is not that strong. Or a paper I can tear because the force is not that strong. But can the same be done with an iron rod? Can I break the iron rod? No, it's not possible. Why? Because the force of attraction is very, very high. So I cannot put my hand inside the iron box because there is no space for my hand to move, or they are tightly closed, or they are having a lot of force between them, right? So these are the different characteristics, and there are activities for describing these characteristics. You have to be literally thorough with each activity. Okay, so now we will see different states of matter. But before we go into that, I mentioned something called a particular particle can go inside the particle of another one. For example, when I am making a nimbu pani or lemonade, I am squeezing that lemon juice, it will go inside the water molecule. Then I add sugar or salt according to my choice, that will also go inside the water molecule. So here actually intermixing of the particles are happening. So this intermixing of particles of their own, of different matters, is called a diffusion. The same way when I am burning an agarbatti or incense stick in one side of my room, how can the smell come to me? Because the particles of that smell or that agarbatti, the smoke, is getting mixed with the air and coming. So there also it is diffusing. Or you take a beaker of water, add one drop of ink. If you stir, you know the entire solution will become blue. But don't stir, just put one drop of ink into water and wait. After some time you can see it slowly mixing. That is nothing but diffusion. So diffusion of gases is very fast because they can move faster, they have a lot of space. Diffusion in liquid is comparatively slower than that of gas, but still it diffuses. But when it comes to solid, diffusion is the least. But can diffusion happen in solids also? Yes, of course. Today I was writing this, but after 2 months I was writing on this board because I was on my vacation. So before going, I had written another topic on the board while I was making a video. Today when I came, I found it very difficult to rub this board. Do you know why? The ink was actually diffusing into this one. So, or when I write with a chalk on the blackboard, the same day if you rub, it will go. After 2-3 days it's very difficult because these solids also diffuse slowly over a period of time. So diffusion in solids is very slow. Diffusion is a process which is depending on temperature. When the temperature increases, the kinetic energy of the particles increase. As a result, they move faster and diffusion rate increases. And when temperature decreases, rate of diffusion will decrease. Now we will see the 3 states of matter. As I mentioned already, the 3 states of matter are solid, liquid and gases. Let's have a comparative study of the characteristics of all of them. First of all, if you see shape. Solid, if you see, they have a rigid, definite shape, right? For example, anything around you, if it is solid, it has a shape. It is not changing its shape, right? Whereas liquid does not have its own shape, but it takes the shape of the container. You take an example. You have some maybe some blocks that you are going to you are playing with, or some marbles. So if you are filling one container with the marbles or the blocks that you have, but still they have their individual shapes even though you are putting it in the container. But liquid is not like that. The water you are pouring into a glass will take the shape of the glass. If you are pouring into a water bottle, it will take the shape of the water bottle. If you pour it into a plate, it will take the shape of that plate. So shape keeps changing for liquids. Again the same with the gases. Gases also don't have a definite shape. They occupy whatever space available. Now second thing is about the volume. Solids have a definite volume. Even liquids also have their own volume, but gases don't have volume. So solids have definite shape and volume. Liquids don't have shape but has volume, whereas gases neither have shape nor volume. Now coming to their compressibility. You can compress gases greatly. Solids, very less compressibility. Liquid also less compressibility. The examples are, we are using LPG gas, liquefied petroleum gas, in our kitchen. It is the condensed gas into cylinder. So large volume of gas can be condensed inside a gas cylinder, which we can use for maybe 1 or 2 months. Or another example here is the oxygen cylinder. When some people are taken to hospital in emergency, they are given oxygen mask. From a cylinder, oxygen is taken. So there also they have compressed oxygen into that cylinder. Or another example is CNG, compressed natural gas, which we use as fuel in vehicles. So that also compressed form. So compressibility is high for gases. Coming to density, solids have maximum density, liquids have moderate density and gases have the least density. And type, if you see, solids are very rigid, liquids are not that rigid, medium, whereas gases are not at all rigid. Or we can say that liquids and gases can change their shape and flow, so they are called fluids. So fluid, usually we think fluids are only the liquids, but gases are also fluid because they can flow. Now coming to force of attraction between particles, in solid it is very strong or maximum, in liquid it is moderate, in gases the force of attraction is very less. About the space, as we mentioned, solids have the least space, liquids have moderate space between them, and gases have the maximum space. So please understand this characteristics very well. So if you see, the particles of solids are kept very close, liquids little far away, whereas in gas they are very far away. As a result, here the force of attraction will be very high. Here the force of attraction is less, here it is the least. So when you are taking a gas in a container, you know that these particles are moving and they are hitting each other, and they also hit on the walls of the container. So thereby they exert a pressure on the container in which they are kept. So that's why when we are taking any gas inside a container, it will exert a lot of pressure. If you like my videos, please share with your friends. If you have not subscribed to my channel, please do so. Thank you for watching Biology My Passion.